In this video, we're going to see the full Gauss-Jordan elimination algorithm. And that algorithm has three phases, one of which we're familiar with from the last video on Gaussian elimination. And that phase is the forward elimination phase. So that's exactly what we did in the last video. Then we do some scaling, and then we'll do backwards elimination. And if you know forward elimination, backward elimination is basically the same thing. It's literally exactly backwards. So the goal of all this is to end up with a matrix in reduced echelon form. The operative word there being reduced. So that forward elimination, the Gaussian elimination, gives us a matrix in echelon form. In this algorithm, we're going to go all the way to a reduced echelon form. So let's start with an example. All right, so starting off with this augmented matrix, we just are going to start by performing that forward elimination just like we did in the last video. So we'll start by finding a pivot, and we know we need to get those entries to be 0. The second entry in this column is already 0, so all we have to do is 0 out this last entry. So we're going to do that by taking row 3 and subtracting half of row 1. And once we've performed that operation, we'll end up with this matrix. Okay, so now we move on to the submatrix and do the same thing again. Find our pivot and 0 out that entry below it. So to do that, I'm going to take row 3 and add 1/6 of row 2. And after we've done that, we'll have this matrix. And now we're going to move on to the next phase. So now our forward elimination is done. You can see we've got our matrix in echelon form. If we wanted to stop here and do the back substitution, we could, but we really want to see this full algorithm. So the next phase is the scaling phase. And the idea with the scaling phase is we're going to look at our pivots that we've used here. And we're going to get all of them to be, we need them to all be 1. So we're going to scale by an appropriate factor. So I'm going to take half of row 1, and that's going to be my new row 1. I'll take 1/3 of row 2, and that's going to be my new row 2. And row 3 already has a 1 where I want it to have a 1, so I don't have to do anything there. And after I perform this scaling, I'll have this matrix. So for all of these steps, if you're not quite sure how we're getting from one to the other, you should pause the video and just check to make sure you can see how it's done. All right, that's the end of the scaling phase, and now we do backwards elimination. And the way the backwards elimination works is going through and, we already have our pivots identified. What we're going to do is start at the bottom and use those pivot entries and multiples of them to 0 out the entries above. So for example, here I'm going to take row 2 and subtract 2 times row 3. And here I'll take row 1, and this also has a 2 in it, so I'll just do the same thing, minus 2 times row 3. And after I do that, I'll have this matrix. And now we can move on to our next pivot entry, which is going to be this middle one, and do the same thing. Right? We're going to 0 out all the entries above it using elementary row operations. So in this case, I'm going to take row 1 and subtract 1/2 times row 2. And after I perform that operation, I'll have this matrix. And this matrix is finally in reduced echelon form, which is our goal. And I can see that because our pivots are all 1s. The leading entry in each row is a 1. There are 0s above and below each of those. And now I can actually, if this is a linear system I'm working on, I can just read off the solution. It says x2 is equal to -1. And x3 is equal to 1/2. All right, so that is the solution to our linear system. So here we go. This is an augmented matrix for a system of 3 equations in 4 variables. And let's just start the algorithm so see if we can find the solution. We'll start by finding our first pivot in the forward elimination phase, and then do the work that we need to do to 0 out the entries below it. And After performing that row operation, we're going to get this matrix. And now we need to move on to the next pivot. And to zero out the entry below it, we'll need to take that row 3 and add to it 3/4 times row 2. And again, recall that to get this 3/4, I'm just thinking about what I need to multiply 4 by so that when I add it to -3, I'll get 0. And after we perform this elementary row operation, we'll get this matrix. All right, now we have finished the forward elimination phase of this process. We can see that because there's no rows below this to look for another pivot. So now we're going to start with the scaling phase. We just need to work with our pivots. So I can see 2 of them are already 1, but to scale that first row, I'm going to multiply by 1/2, and that's going to give us this new matrix. And now comes the backwards elimination phase, and again, we only need to work with our pivots. So that's our first pivot in the backwards elimination, and I can see it's already got zeros above it. So I'll move on to my next entry. I don't need to do anything in the backwards elimination phase for this first pivot, but the second one I am going to have to do something. Right, I'm going to need to subtract 1/2 of row 2, and that is going to give me this matrix. And this matrix is in reduced echelon form, as we were hoping, and I can just read off the solutions now. So this one says x1 is equal to 0. This second one says x2 plus 2x4 is equal to 2. The third one says x3 plus 2.5 x4 is equal to 4.5. And if we just take a moment to note, there's no pivot in this last column, and that tells us that x4 is free. So when we write up our general solution, it's going to look like this. So we'll have 0. For x2, we'll have 2 minus 2x4. And for x3, we're going to have 4.5 minus 2.5 x4. And x4 is free. So that's our general solution, and now we are all set.